The section on the division algorithm starts by a discussion of integer division. And remember, integer division only produces the integer portion of the division. So for example, if I do 10 divided by 2, that value is 5. But if I do 10 divided by 3, that value is 3. I don't count the decimal portion because, again, it's integer division. I only want to know what is the integer value after the division. So 10 divided by 2, 2 goes into 10 evenly 5 times. Real quick note, if I take this value, the divisor, times this value, that gives me my original number. Just keep that in mind, okay? And if I take this one times 3, because I know that the remainder here is 1. So this would be 3 times 3 plus 1. This is 2 times 5 plus 0. That will kind of come in handy later when we try and do some problems. But the integer portion, 3 goes into 10 evenly 3 times, which is 9, with a remainder of 1. The next part in the Xi books on this section is quotients and remainders. Let n be an integer and let d be a positive integer. Then there are unique integers, q and r, where r, the remainder, is greater than or equal to 0. As you can see, the first problem it was 0, the second problem was 1. But it's also less than the divisor. So that really comes into play when we're dealing with the negative numbers, and we'll see that when we do some examples. But in this case, the first one, d, would have been 2. So the remainder could either be 0 or 1, and the second part such that n is equal to q times d plus r, which is kind of what I showed you here. Okay, that this value here, n, is equal to, okay, we write the equation for q and r. The quotient is equal to n div d. The remainder is equal to n mod d. Let's take a look at some examples. The first thing I want to go over is how to do the integer division with the integer algorithm. So this is, the division algorithm. So this has an input that says integers n and d, where d is greater than 0. And it says the output is q equals n div d, r equals n mod d. And so on the left-hand side here is the case where n, the original value that we're trying to divide into, is greater than or equal to 0. The right-hand side is when n is less than 0. So we're going to start with this first one, and we're going to say that 23 is n and the divisor is 5. Okay, if I follow through this algorithm, I'm going to go ahead and say that q starts out at 0, r starts out as n, which is 23. Okay, so I get the values from there. Right now I just executed this step and this step up here. While r is greater than or equal to d, so 23 is greater than or equal to 5. So now I say that q, I'm going to add 1 to q, and I'm going to change r. R is going to be whatever r was before, 23, minus d, so minus 5 gives me 18. Okay, and I go back up, r is still greater than 5, so I do the